So we're just about ready to ramp up to our last topic, which is how to construct data structures. Now, data structures themselves can get very complicated. In this course, we're only going to talk about a very basic one. But before we can do that, we need to learn how to break a couple of rules. And in particular, we need to be able to break the rules of scope. And I suppose looking back, if you remember from September, me talking about the rules of scope and how they're complicated and weird, you sort of feel cheated to learn that in late November, oh, there's actually a way of breaking them. But trust me, when we're done with this, you'll agree that it's sort of better that we have those rules to begin with. Because if you choose to break the rules of scope, if you want to work around them, you end up taking on so much responsibility that the trade-off isn't really worth it. Sure, you don't have to worry about things getting automatically created and destroyed, but on the other hand, you have to worry about manually creating and destroying them. So before we talk about that, let's talk about some reasons why the rules of scope don't really work for us in some cases. So the first one is this lingering question from October, which is why can't we return arrays? So we know all along, we've seen in the last couple of assignments and in countless examples and midterm questions that the standard way that we work with arrays and functions in C is if a function's job is to produce an array, we pass the array in. The caller creates the array and then passes it to the function to fill up with data. But that's a bit weird because we're used to in lots of other functions, even functions that return things like structs. If a function's job is to create something, the function creates it and then returns it. So why can't we do that with arrays? And this is a proof of concept example that hopefully can show off why there's a problem. So first, I don't know how to return an array, but I know that the name of an array, like A, is equivalent to an int star. So I'll write a function that returns int star. And we know by now that we can treat the name A like an int star. So I'll create an array A in this function. It has size 5. I will fill it up with data, and then I will return it. And if that works, then I should be able to call the function in main, take the pointer it sends back, and then iterate over that array and print out the values. Okay, so first, what happens if I try and compile this? Right, well, the compiler gives me a warning saying function returns address of local variable. So local variable would be something that exists that's created in the scope of the function. Okay, so fair enough, that is what I'm doing. Why does it give me a warning about that? Well, I've written that it's a bad idea. Did the compiler notice that and warn me about it anyway? What if we try running it? Okay, so I've added some print statements to indicate where the problem's going to happen. So here's in main before calling f. Okay, well, clearly I renamed the function from f to this. Sorry about that. Then I call the function. That seems to work because I then print out in main after calling f. Okay, and then I get this. And we know already this is the generic message, your program crashed. Certainly we don't see ourselves printing out any numbers. And I could even, for extra reassurance, I could add an extra print statement down here that will print out if we ever get to the end of main. And spoiler alert, we don't. So the program crashes. What's the problem? And I can sketch a diagram. The rules of scope are the reason, and to be honest, we don't really care about this often enough to need to worry about it up until this point. But here's basically what's happening. So I can draw a quick diagram to sort of do a pseudo trace of this. So I have my function main. I create this variable arr, which is an int star. And then I call that function. So here's my function over here. Here's the scope for that. It is separate from the scope of main. The function is called make an array. And we know the usual rules for allocating an array. We create our array A, and it's an int array of 5 elements. And then we fill it up with values, just like we're used to. All right, and it's an int array. And then I return the name A. And I could elaborate a bit on what's really happening here, because really what I'm saying is something equivalent to this. I'm creating a pointer to the first element of A and then returning that. So we could actually write it just like this. It's exactly the same either way. It's just a question of whether we're explicitly viewing that pointer or not. So if I write it this way, we now have this pointer called P. And P is set to the same thing as the value of A, which is an arrow pointing at element 0 of this array A. And then I return the value of P. And if I just returned the value of A, I'd get the same effect. So what gets returned? Well, let's see. What's in the box called P? Oh yeah, it's an arrow pointing at this element here. So what gets returned to main and ultimately stored in this pointer in main is an arrow pointing at this. Well, that's all well and good. So this array does point at this thing of 5 elements. So what's the problem? Well, the problem is after the return statement executes, the function ends. And all along, we've known the rules for this. When the function ends, its scope is gone. Okay, so let's actually just go and destroy it. And then I have this problem. That pointer that main ended up with still points to something. It's just something that doesn't exist anymore. And so if I try using it, if I try following the arrow to retrieve an element, the program crashes. And so the reason why we can't return arrays is that when we create an array inside of a function, we're creating a block of storage that's in the scope of that function. But when we use the name of an array to return it, all we're returning is a pointer to that block of storage. And then the block of storage gets destroyed along with the scope of the function. So the only real remedy to this problem of needing to create an array inside a function and then return it would be having some way to create an array where the storage isn't stuck inside that scope of the function. Okay, fair enough. We've had a way around that for more than a month now. Create the array in main. That way it still exists when the function is over. Why doesn't that work in general? Well, certainly it would work here. I could make an array of size 5 and just pass it in for the function to fill up. But maybe there are cases where main doesn't know how big the array is supposed to be. Main just wants the function to create an array, and it doesn't know in advance how big the array is supposed to be. And so maybe there are cases where we need to create an array inside a function and then return it. So that's the first step that we have to take. We need to be able maybe to break those rules of scope for that purpose.